Okay, so what is it this question is saying? Well, my notation looks kind of funny. It's basically saying the sum from n equals 1 to infinity of minus 1/8 to the n minus 1. And the question is it does it diverge or converge? And if it converges, what's the sum? Okay, so they're giving us that sigma notation again. This is sigma. It's a Greek S. It's a Greek S called sigma. That's the name of the Greek S, which stands for sum. It means add them up. So basically, it means take this formula, let me bring it down here. It means take this formula, take n equals 1 and plug into the formula minus 1/8 to the n minus 1. And then it means take n equals 2 and plug into the formula minus 1/8 to the n minus 1. And then plug in n equals, oops, go with the same color there. N equals 3 to the formula, etc. So let's do that. So when I plug in a 1 there, plug in a 2 there, plug in a 3 there. What do I get? Minus 1/8 to the 2 minus 1, minus 1/8 to the 1. I'm just going to get a decimal, I think. It's minus 0.125. This next one will be minus 1/8. Oh, wait, did I plug in the wrong thing? I'm such a goofball. Yeah, I did. Let's try this again. Minus 1/8 to the 1 minus 1, right? Which is 0, which is 1. Anything to the 0 power is 1. This one will be minus 1/8 to the 1 is the negative 0.125. Now this one will be minus 1/8 to the 3 minus 1 squared. And I'm getting positive 0.015625, and etc. So that's what's going on here. They're wanting us to add up. Remember, then this is a Greek S for sum, add them up. So it's wanting to add, they're wanting us to add these up. So basically this means it's 1 plus, and the negative 0.125 plus 0.015625 plus, on it goes. So they're wanting us to add those terms up. That's what that means. So I just took the sigma notation, which means plug into this formula from n equals 1 to infinity. So I plugged in 1, 2, and 3 just to get started, found out the first 3 terms, etc. Now let's find the R. What is the R? You go down to the notes here. R is the ratio second term over first term. So what is that? R equals second term over first term. What's the second term right here? So that'll be negative 0.125 over first term 1. So that's easy math, negative 0.125. That's there. That's the ratio. In other words, that's what's being multiplied every time. You could test that, right? If to go from this term to this term, you go times negative 0.125. And that's obvious. 1 times negative 0.125 is negative 0.125. And then you just do it again, times negative 0.125, and you will get this term. Anyway, that's what's being multiplied every time. That's the common ratio. So what? Well, then we're trying to add these up, aren't we? Right? That's this is the symbol is a Greek S, which means add them up. That's why I have the plus signs here. We're adding these up forever. So what's the formula for adding things up forever? It's right here. S sub infinity, it's infinite terms. For the sum of an infinite number of terms, it may only be used when R is between negative 1 and positive 1. If R is bigger than 1 or smaller than negative 1, then you just say it diverges. You can't use the formula. So let's go back and say, all right. What is my R? Is my R between negative 1 and positive 1? That's the big question. Where's my R? Well, here's 0 in the middle. It's about right there, isn't it? R is negative, 0.125. So yes. So that means it's okay to use the formula. If it was not okay, if it was not in that interval, we would just say diverges and be done. But we can use it. So the sum then, S sub infinity, is A1 over 1 minus R. So it's A1. What's A1? Well, that's just 1. Here's A1 right here, first term. It's 1 over 1 minus, and what is R? Careful here. R is itself negative. Back that up. Negative 0.125, right? So therefore, S of infinity equals 1 over 1 plus 0.125, right? The double negative, so watch out. That's easy mistake to make. So the formula says 1 minus R in the bottom, and R turns out to have its own negative sign. So double negative positive, you know the drill. So then this equals what? 1 over 1.125. Divide that on your calculator. That's what I'm going to do. I'm getting 0.8s forever. Is what it does. 0.8, X puts a 9 at the end because it just rounded the last spot. So it's 0.8 forever. So there we go. We found the infinite sum of that series. A series that goes on forever actually adds up to a finite total, which is interesting. So that's the answer. So we'd say converges. That means there's an answer. It converges. It comes together. And the answer is, you can put in as many 8s as you want. I don't know. Put in at least 3 or 4. Don't put in ... Just put in a bunch of 8s. Yeah, so it converges. So again, if the R was not between -1 and +1, like if R was out here, smaller than -1, or over here, bigger than +1, if it was not between -1 and +1, then we would have said diverges. We would have chosen diverges, and that we wouldn't have needed an answer here because there is no answer. It diverges. You can't use the formula. It takes off. It doesn't converge to an answer. But ours converged, meaning R was between -1 and +1. So it was okay to use the formula. We used the formula, and we got this answer. So there we go.